So today's our main agenda is to understand about the VMware vSphere clusters. So when we say VMware vSphere cluster, it means we are talking about a grouping of ESXi host. And when we see from customer perspective, production environment where we looks about the redundancy factor and high availability. So when we say an high availability, we just assume a presence of any component, whether it is your ESXi host, your virtual machine, network card, storage adapters, or the entire site, there should be a redundancy. So redundancy means there should be an secondary or another component that will take care of the failure of that particular component. All right. So under this module, we are going to cover about VMware vSphere cluster overview. What is the VMware vSphere cluster? Then we'll talk about the distributed resource scheduler, introduction of high availability in vSphere cluster, vSphere high availability architecture, and how to configure the vSphere HA, and introduction of VMware vSphere fault tolerance. Okay. So about lesson 1, where we talk about the vSphere cluster overview, we'll see the overview of cluster and its benefit, create the vSphere cluster and view the information of vSphere cluster. So in general term, when we say vSphere cluster, a cluster is a group of multiple ESXi hosts. Those hosts share the resources with each other to avoid any host failures. So for an example, if we are using in vCenter server, like for an example, there is 16 ESXi nodes. This is just an example. So we can make a logical group. We can do a grouping of these ESXi hosts together and just present them a cluster. So cluster simple means cluster meaning, if you will read anywhere, what is the meaning of cluster? Just a grouping. And we can contain up to 64 hosts in a single cluster. All right. But again, to this cluster, like this is just an example. This is a cluster. This is the symbol of cluster actually. You see here under this icon, these all are my clusters. These all are my clusters. So each cluster can have the multiple ESXi host, and how much maximum, how many? 64. And if you will say how many clusters we can create in vCenters and all, so there is no limitation of creating of cluster, but yes, for each vSphere version, there is a limitation of managing ESXi host and nodes. It all depend upon your vCenter server version. Probably you remember there is a configuration maximum guide that you can easily search on Google, vSphere 7 or whatever version you are using, configuration maximum guide. As per that configuration maximum guide, you can check the max configuration for each and every component, whether that is your cluster, host, VM, you will get all the details. So it's vary version to version. Then when we create a cluster, so under a cluster, we can enable multiple features, like we can enable distributed resource scheduler for the load balancing of your virtual machines to different hosts, vSphere high availability that protects us from any host failure, and vSAN also. These all the features we can enable. Along with HA, we can enable fault tolerance also. Fault tolerance is primarily to make a replica copy of virtual machines to another host. That, yeah, definitely we are going to talk about too much details. But for now, just for an understanding, all these features can be enabled under the cluster section when we are creating the cluster. All right. So when we typically simply do the cluster creation, like under each clusters need to be created under a data center, under a data center inventory. Then we can add the new host, or we can, like for an example, within this data center, there were some ESXi hosts were already available. Those are in non-cluster mode. Those can be drag and drop later into the cluster. We can add new host, or we can drag and drop multiple hosts inside the cluster. Like for an example, when you will start, then you will go to quick start. then under quick start, either you can skip it and you can do it manually, or you can follow the instructions from here as well. So at a time, a host can be a part of one cluster. A host cannot be the part of multiple clusters. Alright, same way for once we'll go the manual configuration. There is a tab of configure. Under configure, we enable the DRS and availability feature. While you remember for vSAN, I showcase you something. For vSAN, there is a separate tab that is available. When we will drag it down, you will enable the vSAN services. So from here, you will enable HA and DRS, high availability and DRS feature, and their subsettings. Same way for HA also, like for an example, it is turned on for DRS. Same way under this section, you will get the vSAN. So add a host, like as I said, you can drag and drop any host. This is the symbol of single host. You can drag and drop, or you can just right click and add new host also. There is the multiple way of adding the host into the cluster. So when we say the host removal, so any host we need to remove, we have to put in maintenance mode, and we can again drag it back from the cluster. All right. So like as I said, once you will create a cluster, when you will see the cluster summary, the cluster summary will show you the overall total resources. When I say total resources, it means is that, like for example, in this cluster, I have added 4 ESXi host. Okay, 4 ESXi host. Each host have, like for example, each host have 13 gigahertz of CPU. Each host have 512 GB of memory, and we are using a shared storage, like for example 5 TB. So then it will show the total of this. Like for this example, it is showing me CPU. Total CPU is 16 gigahertz. It means that this is the total of amount of gigahertz of CPU that is getting by the number of hosts are added in this cluster. Same way for memory, it's again a total memory, 24 GB, and it's again a total shared storage. When I say shared storage, it is not an individual storage. How much storage being shared among the hosts, those are participating in this cluster. All right. Are we clear so far?
Yes, sir.
Any question? Siva, Suresh, are we good so far?
Sir.
Okay.
Yes, sir.
All right. So in the cluster, we can use some resource reservation as well. So when I say the resource reservation, like for example, for some of the VM, we have given some resource amount as an reserved amount. So when I say reserved amount, so that capacity will decrease. Like for example, my cluster have totally 16 GB of RAM, and out of them 6 GB being reserved for a specific virtual machine. So it means that then that point of time, my usable memory only 10 GB, because that is being fixed, that is being reserved. Same way for CPU and storage also. So that's all, like just in brief introduction. What is cluster? What all features we can enable? How do we enable the cluster? And how we'll drag in and drag out the host from the cluster. Any of the cluster you want to delete, first of all, you have to bring out all the hosts from the cluster. Or if you will, you can directly right click and delete also. Then all the cluster configuration will be gone away. Then your host will be back as an individual host, as a single host. Okay. All right. So lesson 2 is more talking about the DRS. DRS stands for Distributed Resource Scheduler. So when we say distributed resource scheduler, that is something that's going to be balance your VM and put the best placement of host, best placement of VM on particular host. So under this lesson, yeah, we'll talk about what are the key features of DRS, how DRS determine the VM placement in the host, enable DRS cluster, and monitor the DRS cluster. So when we say about the DRS, so what is the main function of enabling the DRS on the cluster? So first of all, to enabling the DRS cluster, for any of the cluster, we required a VM kernel port should be configured, especially for vMotion function. That is the mandatory requirement. Okay. Second, they should have a shared storage, underline shared storage. Okay. So these are primarily two requirements. So when what are the key functions of DRS? It will do the initial placement of the VM when it is power on. It means that is like, for example, we have enabled a feature DRS among these hosts. And if we want to power on any of the virtual machine that is in the shutdown state, so it will log in on the host which is less used. It will power on which host is less used from perspective of your resource, CPU and memory. So that's why it gives the best placement so that to that VM so that the VM can get the optimized resources. Second feature, it do the load balancing. So when we say load balancing, it means that is like, for example, in this, if this host have multiple VMs, this host have running multiple VMs, and this host does not have too many VMs. So it means that is there is less load of virtual machine on second host as compared to host number 1 and host number 3. So what it will do, automatically, it will trigger the migration of the VM to the next available host where we have more resources available as compared to the host number 1 and host number 3 in this example. So it will migrate to 2. Then third key feature of DRS is migrating VMs when ESXi host placed in maintenance mode. So what is maintenance mode? So maintenance mode is primarily whenever we are doing some patching activity, some update activity, or some hardware replacement activity. So my host will be in power on state, but it will not take any current working VMs and all. So once I will right click and I will put maintenance mode, so it will trigger the migration of all these virtual machine to the rest available ESXi host. It will get free up. All right. So that's again a feature of DRS. Once you will enable maintenance mode, it will automatically trigger the virtual machine migration to the next available ESXi hosts in that cluster. But yeah, after it will come back to from maintenance mode, that's a feature of your cluster. It will do automatic load balancing, or you can do some manual VM migration to this back ESXi host. All right, are we clear? Or what are the key three features when we enable the DRS? Yes, no?
Yes, sir.
Yes, sir.
Okay, all right. Okay, so vSphere DRS is primarily the feature of VM focused. So when we say VM focused, it take care of the VM power on. It will take care of the VM placement, initial placement. It will create the best resource requirement of the VM, and it will always give some recommendation sometime, and it will trigger the virtual machine migration from the one host to another host. So the main function of it's just to do the resource management properly and just do the load balancing. When we say load balancing of the resources by moving virtual machine here and there and powering on the right place. Okay, so when we say about DRS score, so when we enable cluster on DRS score, there will be two value, 0% and 100%. So when we say 0%, indicate the resource contention. So resource contention means is that, like, for example, here we will see VM DRS score is lesser. It means that we are getting resource crunch in that. So if my score is near to 100%, it means that is no resource contention. So each of the cluster, if we get the resource from 80% to 100%, it means that my cluster is appropriately balanced. And like, for example, if you will say for some of the VMs, like just for an example, I would say for two VMs, we are getting the DRS score between 0 to 20%. It means that there is some resource crunch for this VM. They are not rightly placed, right? They are not rightly placed on that particular host. So in that case, we have to just, DRS will trigger the migration for these VMs to the next available free host. So more score is good condition, less score is the bad condition in percentage. Okay. Okay, so how can we check the VM DRS score particular virtual machine? So it's again once we'll enable the DRS feature, here is the VM DRS score, and you can check the DRS score here. So I believe these are all good because they are falling somewhere between 80 to 100%. So it means that percentage of resources high. It means they are getting their desired resources from the underlying ESXi host. They don't have any problem. Okay. All right, so this is my overall DRS score that I can, if I want to export a report, so I can export a report and I can put a cluster name and I can do the duration also, and I can export it as a chart also or any Excel format. So how we'll check it? So that's what I just told you in DRS setting. There is a tab of checking the DRS, overall DRS settings also. So once you will click the DRS, you can check this is my fully automated mode or partial or manual. That's 3 mode of DRS. Okay, so automatic level means that it will automatically trigger the virtual machines. Like for an example, as I given you one example just away, like one VM where its score is 10% or 20% something. So it will automatically trigger the migration of that VM from one ESXi host to another ESXi host. Yeah, so that's the main key when we enable the DRS. So once you will just toggle this button from gray to green, you will get these settings. First setting is there is 3 options: manual, partial automated, fully automated. So when we say if we'll select manual option, so manual means is it will only taking care of the initial placement of the VM, power on the VM on right host, but it will not take the guarantee of how I should migrate it, or if in case resource crunch, then no recommendation. Initial placement will be done by this option, but it will not trigger any kind of vMotion if in case any resource crunch available on that particular ESXi host. Second option, when I say partial automated, under partial automated, it will power on the VM on right host, and also it will give the recommendation like the VM have less score, you need to migrate this VM, something like that. But again, it will not trigger the VM migration. If I will say fully automated, it will take care of all 3 functions: initial placement, recommendation of that VM migration, and also perform the migration for that particular VM. So the best practice is to keep it as an fully automated. All right, fully automated. So fully automated, we will getting all 3 function: initial placement of VM movement recommendation from one host to another host, and also it will trigger the migration. So when we say migration threshold, so threshold is the value like how eager my VM is able to jump from one host to another host. That's we call migration threshold. By default, there is 0, 1, 2, or 1, 2, 3, 4, 5 values. So 0 is most conservative. When we say most conservative, less frequent vMotion. Less frequent vMotion means is vMotion will happen, but in a very conservative manner. When I say conservative, when this host will feel too much load, then it will only trigger the vMotion, else it will keep on running. So it's a lazy state actually. When I say aggressive, more frequent vMotion. More frequent means if, like for an example, 10% load comes extra on this, it will trigger the migration. So maybe 10% load is here, it will again trigger the migration. So normally to keep more aggressive and more conservative is not a good practice. So by default, we will keep it as a medium value. We'll keep it as 3. No much aggressive, no much conservative. Right? Enable the virtual machine automation. It will automatically migrate. And the predictive DRS. So predictive DRS feature is normally enabled with the help of vRobes. When I say predictive, there is some prediction. So when I say prediction, like for an example, these hosts are turning number of virtual machines, and today my vRobes analyze the trends of virtual machine resource load. Maybe it's assuming after 2 days, this host will utilize CPU and memory approximately 70%. All right. So vRobes will recommend you after 2 days or 3 days, your VM will not be, your host is not more capable to run these VMs here. So it will insist you trigger the migration in advance on the place right host where, like after 2 days or after 3 days, whatever trends say, it will get the appropriate resource. So predictive DRS only we should enable when we have integrated the vRealize operation manager with the vCenter server. Okay. We good this tab? Yes, no? Are we good?
Yes, sir.
Any question? Siva, Suresh, Pramod? Are you guys there?
Yes, sir.
Sir, this predictive DRS,
Mm-hmm.
I have doubts on that.
No problem.
How this works,
So,
sir?
simple example. Today, you are working some work, Pramod is working some work, Suresh is working some work, and I have give equal works to each of all, right? But I have assumed on the basis of Siva is resolving some tickets, and I assume I am the vRobes, so I am your monitor. So I feel that, yeah, whatever the trend say, after 2 days related to this particular technology, Siva may get the more tickets. So I have analysis in advance, all right? So I will distribute some workload to another guys. The same way here in VMware, like for example, each host running 20 VMs, but their CPU memory configuration is different. What I feel, on first host, what I feel means what vRobes feel. On particular first host, I feel the trained VM are consuming the resource. In next 2 days, on the past history of working their resource utilized, next 2 days, this host will not be capable to run these virtual machines, because as the way I see, their utilization is increased day by day, day by day, day by day. So vSphere vRobes will recommend to migrate in advance to the available host where sufficient resources will be available for those VMs. Clear? Predictive is a prediction based DRS. It's not a current DRS. Current situation is a host got much load. I have set it fully automated. So it will take the decision on current situation, but it will take the decision of in advance on the basis of vRobes analysis. Okay, your DRS, your migration will happen in advance itself. All right. Clear, Siva?
Yes, sir. Got it.
Okay. Okay. So that's I told you right away. What is the meaning? I told you this predictive DRS also. Okay. So vSphere DRS setting, VM swap file. So swap file are additional files that goes created by the virtual machines in a ESXi host. That's whenever a high memory conservation happens, that will be. So whenever any VMs will trigger, normally swap file will migrate for that VM only. So we can set the setting, where should I keep my swap files, or I can define the specified data store locally. All right. So normally people keep along with virtual machines, but yeah, in rare cases, like I would say for this virtual machine, swap file will not be on shared data store. This is my shared data store. All right. So as I said, like by default, it is, this is my VM file, this is swap file. This is my VM file, this is swap file. But in some cases where customer use the swap file in a local data store of ESXi host. Okay, so that time if swap file is allocated in local data store, so in DRS setting we have to choose this option. For that, this swap file will also be migrate from here to the local data store. If on a shared data store, then that's fine. Only my VM's compute will migrate. Swap file will be available on same data store. All right. So in each rule, there is some exception rules also. When I say exceptions rule, like for example, you say, sir, for overall cluster, I have made this setting fully automated, VM monitoring enable, and this level of this. But now I am saying, sir, there are some few VMs I don't want to follow the DRS rules. All right. So here you see add VM. So from here we will add the virtual machine and we will say, like for example, VM1 on particular host is running. I don't want any cost. This VM1 should migrate to another ESXi host. So I can make a rule, maybe DRS disable for this VM or just manual, partially or fully automated. So I can override the DRS rule for the individual VMs also. That's we call the exception rules. Okay. Same way for HA, I'll talk about in HA we have number of settings. Again for HA, we can make the override rules as well against the policy. So by default in a cluster, whatever rules we have made, the VMs will follow same rules. But for individual VMs, if we want to make some exception rule, that's also possible. Right? That's what this VM overrides option helps you.
Sir, in this,
Yeah.
sir, sir, in this, suppose like in ESXi, the ESXi is down. It's down. It has to be moved like VMs to the other ESXi host. So when this
That's
rule
a
is
nice
applied,
question. Let me
yeah,
tell you. If
okay.
the main function of DRS is not responsible to make any failover, the main function of DRS is load balancing the VM. Only the host are in power on state. If you will say, sir, I have only DRS enabled, that's a big confusion actually. And yeah, that's a right question you have raised on the right point. Hear me carefully. If on this cluster, I have enabled DRS, it will only load balance. It will not do any failover. So if I will enable, I have enabled only DRS, this node got fail, no migration will happen. Okay. DRS will take care of running VMs on running hosts. HA is take care of host failure. Okay. So that's why we say in any cluster, we should enable both the features. HA will take care of host failure. Your VM restart to another host. Wherever DRS just do the load balancing of running VMs on current running hosts. Are we clear? Yes, no? Shiva, it's a question from your side. Are you clear on it or not? Shiva, you there?
Yes, sir. I'm there.
Are you clear? HA will
Yes,
take care
sir.
of failover of the hosts.
Okay,
DRS
sir.
will do the balancing of the VMs on current running ESXi host. DRS will not do never ever your failure if host is failure. HA will never do your running VMs load balancing. HA take care of the failover of the VMs. When I say failover, it means that your VM will restart. If
Mm,
any host got failure here, this VM will restart to another
okay.
host, not migrate. Migration will happen, but with restart.
Okay.
DRS will take care of running VM's workload. DRS will, if in case no HA enable, only DRS, host got failure, then VM will be shut down here only. Okay. So that's why to make the best combination, we always enable HA and DRS together. So in HA in details, we are going to cover in next upcoming lesson. All right. So as I say, your requirement, requirement must be the part of vMotion network that I told you. Agar if there is no vMotion network, vSphere DRS still make initial placement is right, but no vMotion will happen. All right, and configure all the host to the shared storage. Okay. All right, so from the DRS cluster monitor tab, where you can see CPU utilization, memory utilization, network utilization. So this is the host level, and this is my CPU consumption of virtual machines on the chart. So here is the chart. We can export also, where we can see the cluster overall consumption, how much. So here is DRS recommendation pane display information, the DRS. Here in the recommendation, fault or history, if any fault is come or if some recommendation is there. So what you need to do in case of recommendation is available, run the DRS again. So if you will run the DRS again, it will rebalance your VMs across the hosts, right? But when any vMotion happen, or any VM migration happen, definitely there is some performance, some minor performance impact on your ESXi host, because they have to do some additional work just to switch VMs from here to there. All right. Maintenance mode that I told you, the maintenance mode remove the host from a cluster, making those resources are unavailable for the moment, and it will move all the running VMs to the host, to another host, or shut down the VMs on particular host. You cannot power on or migrate the VMs to a host right now in the maintenance mode. Okay. So when I say any host have maintenance mode, and if that in maintenance mode, it have a power of virtual machine, can I power on it? Answer is no. In maintenance mode, can we keep power off machines there? Answer is yes. In maintenance mode, can you keep power on virtual machine? Answer is no. In any cost, you cannot power on the VM. Right. So when DRS is fully automated mode, power on VMs are automatically migrated from a host that is placed in maintenance mode to another. Okay, that's a most important point. When you expect the VM should be migrated, my DRS setting should be in fully automated mode. When I say standby mode, a standby mode is a dynamic power management module. When a host is placed in standby mode, it is in approximately in power off state. It's a kind of sleep mode. Okay. And that point of time, we don't expect any VMs are running on that particular host. So remove a host from cluster, always place the host in maintenance mode, then drag host into different directory on inventory. When I say different directory, maybe in another data center or maybe in another cluster. But at a moment, a host cannot be the part of multiple clusters one time. All right. vSphere DRS with the direct IO path. So direct IO path, let's understand first what is direct path IO. Direct path IO improve the functionality by adding the layer of VMs to the PCI devices. So what it means PCI devices, like for an example, one VM is running here, and in my host, there is some PCI card that I have given to this, that I have assigned to VM label. So if any host does not have same family of PCI card, like you could see here is no PCI card available, here is no PCI card available. So your DRS will not allow to move that VM to that particular host. Only the rest of the host which have similar kind of devices available, the VMs will be allowed to move there only. All right. So this is the dynamic direct path IO setting. But yeah, again, if there is some devices we can add the PCI devices from the virtual machine setting. If in some case there is some graphic card or some network card that I have assigned as in direct means is it is a physical device on my physical server, but it will present in a virtual device in my virtual machine, and no another VMs are using that. Only that particular individual VMs are utilizing that. So just better performance as compared to another one. So here is some lab. Create a cluster that is enabled for DRS, add ESXi host, verify vMotion happen, modify the DRS settings, create a load imbalance. Imbalance means just put some more one load, and verify the proper cluster DRS functionality. Definitely we are going to do these all labs, but first let us complete the module. We clear so far?
Yes, sir.
Right. We'll do this lab, don't worry about that in the lab section. So lesson 3 is introduction of HA. HA stands for high availability. So when we say high availability, we expect the high availability on each and every level. You remember in the beginning of lesson, I told you a high availability is nothing just to present of any component more than one. When I say more than one, there should be redundancy. A redundancy should be my network card, it should be storage adapter, should be my paths, in my ESXi host, in my data stores, in my data center. Okay, when I say a component is available more than one, I would say high availability. Availability is higher as compared to the single component. Okay, like here, I took NIC teaming or storage multipathing. That's an example of high availability, correct? When we say NIC teaming, we are using 2 or more NICs together to avoid NIC failure. Storage multipathing to avoid storage failure. And in cluster, we enable high availability and DRS to avoid the host failure. In data stores, we can make a cluster of multiple data stores together, logical cluster of storage to avoid any data store failure. Or if you say everything is fine, sir, can I make a entire data center reprotected? That's also possible. We can make a replica data center to another site where my site recovery manager is a tool from VMware, where I can protect all my VMs to secondary site. If and by any major region, maybe some earthquake, fire, tsunami, okay, it got destroy this particular entire physical location, entire physical data center got destroy. All my VMs will be will start to another secondary site, but it will be a restart. It will not a vMotion or migration. Okay. So in that way, we can do multiple level of protection, all my component level protection. It is my NIC, it is my storage, it is my power supply, any component. Server level, we can do high availability and DRS. Storage level, we can do storage clustering. Data level, we can do the data replication or data protection. And site level, we can make a entire secondary site and we can protect them. So the best design say always we should have a as maximum as possible. We should have the redundancy. We should have the high availability for each and every component. Okay, we good? All right. So when we say especially vSphere HA, so a feature, in case of vSphere high availability, it means that now I'm talking about only the host, not any network, not any storage. These are my ESXi host. I have put in a cluster, and within cluster, I have enabled HA feature, high availability feature. So when I do enable high availability feature in particular cluster, what it will do, it protect from ESXi host failure. When I say ESXi host failure, it will restart the running virtual machines. Like this host got failure, these VMs will be restarted some another host. All right. VM failure. So when I say VM failure, like for example, my host is okay, but I'm not getting appropriate heartbeat from the VM. So it will restart this VM on same host. Host is okay. Problem is with VM. Same way with application failure. Data store accessibility failure. When I say data store accessibility failure, for example, they are using the common shared data store. And for particular host, I found data store path is lost. So the running VMs on this particular host will be restarted to another host. And in take care of network isolation. When we say network isolation, any host is gone away from your network. Like they are not able to communicate for the rest of the host that is out of network. That's also being protected by the HA feature. So my HA feature in vSphere, that protects me against all these failures. All right. We are going to talk details in upcoming slides. So these are my HA scenarios where my so these are some storage failure scenario here. Data store unaccessibility. When we say data store unaccessibility, there could be two reasons: a permanent device loss or all part down. When you say permanent device loss, we are assuming here from the particular host. These are my, let us suppose these are my ESXi host, ESXi 1, 2, and 3. And this path is permanently gone away from there. So what it will do, it will power off and restart the VM to another host. APD, all part down. All part down means this is being expected. My path is down for temporary. It will be back after some time. Okay. So it is recoverable. Response can be either power of restart VM, simple conservative, or power of aggressive restart policy. So again, the time being, my path is down, VMs will be rebooted on another. But yeah, once path will be okay and up and running, VMs will be come back. I mean, come back means it will taken care by the DRS settings. Then protecting against the network failure. So when we say the network failure, we just assume from any of the host, like for example, this host got failed. This host is running, but this is just out of my network by XYZ reason. Network got failure or their IP is being changed. So what will happen on this? So again, these VMs will be restarted to another available host. That's called as an isolation state of that particular, that is isolated now. Okay. So that's why we always keep the redundant heartbeat network to avoid the network failure. So these are the redundant heartbeat network. Heartbeat is nothing, just a hello packet from primary host to your secondary host. So there you see two networks. To achieving the redundancy in heartbeat network is either my heartbeat is by default. If I will draft a picture here, these are my ESXi host, which is my heartbeat network by default. My management network is my heartbeat network, and there would be a master node and there would be the I would say slave. This heartbeat is always generated by master host, sent to your slave nodes and get a response of that. And this is done by management network. So to keep this redundancy of heartbeat network, either whenever you make management VM kernel, map with two NICs, their traffic should go to active NICs, or you can make two VM kernel and two separate heartbeat networks. That's also possible. There's two way. So like this is one example. My management network, that's by default work as in my heartbeat network also when I enable HA. So it is mapped with two NICs. So on physical level, I am getting the redundancy. Okay. So in case of I am using the vSAN network, I am using the vSAN environment. So in that case, my vSAN VM kernel will be used as my heartbeat network. If there's a non-vSAN cluster where we are using simply external storage, then my management network is my heartbeat network. All right, we clear so far? Are we clear so far? Pramod, Siva, Suresh? Shall I take it? Yes.
Yes,
Okay.
sir.
So that is the second scenario I told you. There could be two separate heartbeat, but normally people don't use this scenario. Wherever I have seen the redundancy, my management is mapped with two or more physical NICs. In case of vSAN, it is my vSAN network. Now, let's talk about the HA in detail. What's happened in the background story actually for the HA. All right. So this is the detailed architecture. So when we enable HA in any cluster, a FDM service, a fault domain manager service, it starts by default. You see FDM, 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 and a heartbeat communication happens through your management network and also through your shared data stores. Shared data stores. So there is two medium of heartbeat. One is your management network and second is your shared data store. Again, like for management network, as I said, there should be redundancy. Same way for it refer data store, there should be two data stores for the redundancy purpose of the heartbeat. All right. Come back to FDM. So in this picture, you see probably there is one host selected as master and the other host are selected as subordinate. So how the master host and subordinate host being selection being happen here, there is a management object ID that is being given by your vCenter server. And that's the factor. And second, the host which have more shared data store or a host have the high management object ID. When I say high, like for example, just an example, a host have 98, 99 and 100. These are the object IDs, but it convert into hexadecimal number like this 1111 99 के लिए मैं लिख रहा हूँ 4 टाइम 1 4 टाइम 1 100 के लिए अगर लिखूंगा तो 001 000 000. So in this case, this is not the highest. This is the highest, which have the higher number of binaries. That's considered as the higher number, higher management object ID. Okay. So if in case all the hosts have same shared data store, then my first host will become the master host, and that will directly talk to my vCenter server. All right, let's talk to directly my vCenter server. So in that case, master host will keep on sending the heartbeat and getting the response from the subordinate hosts. And rest of the channel is same. VPXA, OSTU service, you know very well how they communicate with each other. Okay. So, like as I said, master host send a periodic heartbeat. Time is 30 seconds. 30 is max. I think that's 5 seconds. That I'll check and let you know. But yeah, that's a periodic heartbeat to subordinate host, and they were getting from the by default primarily with the network. But if any case this is not available, that will start to send the heartbeat from the shared data stores also. But it will always prefer first as an management network for your heartbeat network. Like as I said, the the second channel of sending the heartbeat is the shared data store. All right, so this heartbeat is primarily take care of any subordinate host failure, network partition, network isolation is happen. That's all being monitored by your heartbeat. Because if any host is not responding, it means that there is some problem in the heartbeat network. So vSphere HA can protect us again the scenario if any host got failure, either that is the subordinate host or master host, any network isolation, any storage and accessibility. So it protects us from all level of failures. Right? So let us assume the different scenario here. If we say subordinate host got failure, how we'll get to know how the trigger? So master host will keep on sending the heartbeat. All right. So if this subordinate host is not responding to 3 consecutive heartbeat to my master host, it means that master will consider that's not more available and your VM will restart to another available host. Okay. Let's assume a scenario where my master host got failed. In that case, what will happen? So in that case, if master host will got fail, if I'll go back to this slide, this is my vCenter. So now vCenter will feel I am not getting any call from my FDM. Okay, from my FDM, my master server, whomever I have elected as a master. So vCenter server will elect a new master from the available host. So it will elect a new master from the available host on the basis of, as I said, the management object ID. And if I will need to elect from here and here, this will be my master. Okay. You know, in binary, who have the more weightage, and this will have the more weightage. And again, these VMs will be restarted. Again, hear my word, restart to another hosts. Are we clear so far? Yes, no? All right. Cool. So what is the state of, I'm just talking about these scenarios only, right? Subordinate host failure, what will happen? Master host failure, what will happen? Now I am talking about the network failure. When I say network failure, we assume any of the host is okay. That's power on, everything is fine. But nobody is able to find that host over the network. Okay. That's called an isolation state. My master is not able to talk to this one. It will send from here. So it will, okay. So it's not getting the response. So the host is not receiving the heartbeat. Second, the host is not pinged to isolation address. What is the isolation address? Isolation address means is my default gateway address. You remember whenever put the management IP, put a default gateway. So that default gateway is by default the isolation address. So abhi, like in this case, this host ping, there is no response. Secondly, this host tried to ping to the gateway IP and it's not getting the response itself. So it means that is in isolated state. So far, no network communication is happening with that particular host. So in that case, what my cluster will take the decision? In my cluster, there have the setting. Like, shall I power off the VM or restart the VM on another host? So if a host just consider in isolation state, I would say, like for example, we have set as restart. So my VMs will be restarted to another host until this host network not come back in healthy state. Right? We clear? Yes, no? Pramod, are we clear? Suresh, Shiva?
Yes, sir. Good from my side.
All right. Yeah, just keep on saying yes, no, okay. Okay, so I'll feel you are there, okay? So there would be a case of storage failure as well. So when we consider storage failure, they go completely storage failure is the complete failure. You cannot do anything in that case, okay? So storage failure here, it's talking about the accessibility of storage. So if, like in this example, storage is right, but for one host, I feel storage got disconnect. So the storage will get disconnect. So it means that the running VMs will not able to access the storage, correct? So what will happen? All those VMs will be restarted to the next available host where my storage is accessible. Okay. All right. So for that, we run a service that is called VMware component failure that we called as VMCP. So this we have to enable VMCP. HA detects the data store accessibility failure and provide the automatically recovery of the affected VMs. If this feature is enabled, only it will detect the storage failure if VMCP is enabled. VMCP is not supported in vSAN, absolutely yes, because vSAN is the local connected storage. Okay, VMCP is only for remote storage, kind of your remote SAN or remote NAS. Okay. All right. So again, we have to design our network, keep the redundant network, keep physical separate network, keep couple of data store. All right. Use fiber channel and keep the separate IP storage for the network that we have discussed multiple times. All right. That's the purpose of this lesson. Okay. Do you want me continue or let's pause it for today? We'll continue next remaining lessons tomorrow.
Yes, sir. Let's
Depends upon
do
your
it tomorrow.
choice. All right. All right. It should not be bounced too much so that you go ahead back and hear the videos again. And if you have any question, we'll take that. And tomorrow we'll cover the lesson 5, lesson 6 also. And let's get some answer in labs also. Okay. You clear?
Sure.
Yeah. Okay, guys. Bye again. And have a good day ahead. So yeah, I'll be sharing the recording. No problem. Thanks.
Thank you, sir.
Yeah. Bye-bye. Take care.